Okay, so 4.4 in behavior. Here we go. Do you all see the cursor now? Good. So here, g of x is what we get when we do our long division, right? Now, r of x is your remainder on your quotient, right? Now, think about this. As your quotient, not your quotient, your divisor keeps getting bigger and bigger and bigger. As the denominator keeps getting bigger, what number is that fraction eventually approaching? 0. So that's why here we write as 0. And that's why it doesn't have a factor. It doesn't factor into what your in behavior is doing, okay? Your in behavior is based off of the g of x. So your g of x is either going to be your slant asymptote or your horizontal asymptote. Okay, so you're going to be one or the other. So let's look back at what we had here. So for example, on example 3, we had x minus 2 plus 2 over x plus 2, right? And x minus 2 was our slant asymptote. Did we see that? Okay, going back again. Here, when we did example 2, when we did our long division, we had 3 plus negative 6 over x plus 2, and 3 was our horizontal asymptote. Do we see that? Okay. And then here, this was already in standard form. And notice, because it's already in proper form, if there's nothing being added or subtracted, what is the number that's there? 0, which is why our horizontal asymptote was at 0, because it was already in proper form. Okay, so that's what that summary is telling you. All right. Now, let's talk about what if you just have the function, the equation of the function, and not the graph or a table. What do you do? So you want to determine the in behavior by analyzing the degree of the denominator and numerator first. So the first thing we're going to do is pay attention to the degree of the numerator and the degree of the denominator. So looking here, the degree of our numerator is, it's 0. And the degree of our denominator is 1. And so numerator is less than denominator. In this case, when your numerator is less than your denominator, it is already in proper form. So since it's already in proper form, I know that I have a horizontal asymptote. At what? At 0, at y equals 0. So that, how does that affect your in behavior? Well, that means as x goes to negative infinity and as x goes to positive infinity, what is f of x doing? It's going towards 0. And that's how you describe the in behavior. You identify the asymptote and say what it's doing, or what it's causing the graph to do. Okay, so on your assignment, you can create the table and analyze it, or you can just use the fact of, let me pay attention to the degree of the numerator and denominator and go from there. Okay, next example we're going to look at is one where we may have to do a little bit more work. All right. So here it says determine the in behavior. So we have x squared plus 2x plus 1 divided by x minus 2. So the first thing, again, you're going to do is analyze the degree of the numerator and the denominator. So the degree of the numerator is what? 2. The degree of the denominator is 1. So this time, the numerator is greater than the denominator, which means that we have to do long division because it's not in proper form. So we're going to do long division. Remember, the cowboy rides the horse, so x minus 2 goes outside. And x squared minus 2x plus 1 goes inside. When we're dividing, remember, divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So we have x squared divided by x. What is that? X. After we divide, we then multiply. X times x is x squared. X times -2 is -2x. After we multiply, we subtract, which means we're changing our signs and combining like terms. -2 plus 2 is 0. And then we bring down. So our remainder is fudge sickles. It's not like I've done this once already or twice. Just make sure you knew what you were doing. And then we bring down. And we're going to repeat again. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. What is 4x divided by x? 4. And we're going to multiply. We get 4x minus 8. Subtract, change signs, and combine. And we're left with 9. So now in proper form, we would have x plus 4 plus 9 over x minus 2. So this guy right here is a what? What kind of asymptote? A slant asymptote. So we have a slant asymptote. Because it's a linear. At y equals x plus 4. So when we write that in terms of our end behavior, what does that mean? Well, it means as x goes to -infinity and x goes to +infinity, f of x is approaching what? X plus 4. Which just means that it's infinite. Either it's going to +infinity or to -infinity. You need to be able to be comfortable writing and interpreting the writing. Yes. All right. I don't know if that's what you meant. Our vertical notes are the ones we took before the break. Yes. Yes. We're only, yeah. When they're approaching, one's approaching +infinity, the other's approaching -infinity. Example 3. All right, let's look at it on a graph just so that you can see. Screen, what is wrong with my computer? Something's out to get me today. I don't see my mouse on my computer and it's, there you go. Found it. All right, here's my handy dandy calculator. I'm gonna go to y equals, well, it should turn it on. And second plus 712 is gonna clear it out for me. So when I go to the calculator to see and make sure that I'm roughly correct, I'm gonna graph the problem. So I'm gonna graph the original. I'm gonna protect my numerator. So I have x squared plus 2x plus 1 divided by, protect my denominator, x minus 2. All right. And now I'm going to click graph. And notice here, what did you notice? Do we see that there's a slant? There's some type of slant that's causing my graph to head in different directions. Okay, the other thing is you can go look at the table. When you go look at the table, I can see that as our x values are getting smaller, what are the y values doing? They're also getting smaller. They're heading towards negative infinity. Do we see that? And then on the other end, our x values, as they're getting bigger, what are the y values doing? They're also getting bigger because they're heading towards positive infinity, which is what you would see on the table, on the graph. And that's that. All right. Again, 4.4 assignment is on the paper, and it's due when? Thursday, which is tomorrow.